Welcome to the CO emissions presentation by Green Canada. CO, or carbon monoxide, is a chemical compound which contains one carbon atom and one oxygen atom, and is also a colorless and odorless gas. In this presentation, we will consider the global CO emissions, the CO emissions in Canada, sources of emissions, strategy to reduce emissions in Canada, and then our conclusion. Carbon monoxide emissions primarily is from combustion of fossil fuels, and this has increased drastically since the start of the Industrial Revolution. The contributing sources of areas in the global economy that contribute greatly to these gas emissions are from a small number of countries like China, United States, and the nations that make up the European Union. Per capita greenhouse gas emissions are highest in the United States and Russia. But of course, Canada, as we know, as a developed country, has its own share too. It actually contributed a total greenhouse gas emissions in 2019 up to 730 megatons of carbon monoxide equivalent, a slight increase from 728 metric tons of carbon monoxide in 2018. And between 2090 and between 1990 and 2019, emissions increased by 21.4%, about 129 metric tons of carbon monoxide equivalent. So we hereby see that Canada also contributes greatly to these emissions. And these emissions are actually increasing as there has increased emissions from oil and gas extraction, as well as the transportation sector. In fact, studies on how to reduce or minimize or eliminate CO emissions was carried out, and the Natural Resources Canada actually developed a calculator that estimated that if 2.6 million passenger vehicles were taken off the roads for 1 year, that would amount to 8.5 metric tons of carbon monoxide emissions reduction, or the energy-based emissions from nearly 2 million homes for 1 year. So we see that cars or vehicles contribute greatly. So if we reduced or minimized emissions from vehicles or eliminated it completely, we will invariably be eliminating CO emissions into our planet. Of course, it's not cheap either to run or burn these fossil fuels in our cars. About $35,000 will cost to run a typical car using fossil fuel. So CO emissions from cars has been identified as a source of CO emissions into our planet. So to reduce emissions, we want to actually eliminate this source of emissions or explore alternatives. We know that of course cars are very important. We require them. We need cars to go to school. We need cars for work. We need cars to transport ourselves around. In the medical field, the emergencies, security, and other sectors of our economy require vehicles, means of transportation. So cars are very important. So eliminating cars will not be feasible, but exploring alternatives is worth considering. And the good news is that electric cars became the most promising technologies for reducing emissions in global transportation. Why? Because electric vehicles do not use combustion engine. Instead, they use electric motors. So they emit no exhausts from the tailpipe, which means that unlike traditional vehicles, they don't dump carbon monoxide, ozone, and particulate pollution into the air we breathe. So electric vehicles actually emerge as a very good alternative for combustion engine vehicles. So for us to make decisions on how to invest in exploring or producing electric vehicles, we want to perform some analysis of the emissions from various classes of vehicles in Canada. So these analyses will help us determine the best strategy we will want to take in reducing emissions in our transportation sector in Canada. So to help us do that, we actually obtain a data set called Euro 6 tests. So this contains emissions for various types of vehicle. So this will help us to analyze the emission that comes from these various vehicles, and it will guide us in our investment plan for green transportation in developing electric vehicles. Based on the data obtained, we will develop a chart that will provide a graphical view of the CO emissions based on various classes of vehicles. And the chart that was developed was the Pareto plot or chart. So this is the Pareto chart of emissions of carbon monoxide for vehicles across different types of vehicles. So we notice that the spread of CO emissions, the two that stand out above the 80% emission level here, level of emissions here, stand out for the two different cars which fall actually among the SUV type vehicles. So this means that SUVs account for highest CO emissions compared to other vehicles. So of course, this means that there are more SUVs on the road. This means they are the preferred class of vehicles by Canadians. Therefore, in our strategy to reduce emissions, we want to, for us to succeed in that strategy, we will think of transitioning to green transportation vehicles that will serve as an alternative for what is readily accepted in the market. So in conclusion, based on our presentation, we have seen that SUVs account for highest emission levels, and that being so, compared to other vehicles, this indicates that they are the most preferred classes of vehicles by Canadians. Hence, in our pioneer investment in green transportation, we will then explore developing electric vehicles that are in the class of SUV service vehicles. So next, we want to consider exploratory data analysis using the Python software. So first of all, we want to see the data that was obtained. The data set here we are using is Euro 6 test that contains the CO emissions for various types of vehicles. So to perform EDA, we had to open up the Python software, and this is our Jupyter notebook. So to begin, we have to import the useful libraries. So the libraries we imported are the NumPy, the Pandas, the Seaborn, and of course we had to import Matplotlib, and all of these were actually in preparation for the analysis we will be performing later on. So then we now performed the load dataset code, which is a pd.read_csv because it's a CSV file, and because our file is in the Python folder, so the Euro 6 latest.csv file was actually uploaded. So to perform our EDA, we perform basic checks on the basic data exploration on our data. First, the data.head to see the first 5 rows of data, and then we now had to look at to see the various columns to check to see if there are missing data set. We have actually seen that here, but to enable us clean our data, we had to use the round 100 data.isnull.sum code. So the intent is to see the missing or null values in percentage. So higher null values above 50 will be eliminated. So that we did by using the data.drop code to eliminate those columns, as you can see here. And then we perform the data.head to just look at our data set again, which we can now see. And then we now did the data.tell to look at our data from the last 5 rows of our data. Then we did perform the data.info to look at this helps us to see the information about our data. We can see the columns and the data type for each of the columns of our data. Then we perform the data.shape code, which enables us to see the rows and the columns. Here we have 6, 7, 6, 5 rows and 32 columns. Then we performed the describe code. This helps us to see how data is spread for numerical values. We can see the count, the mean, the standard deviation, the minimum, the percentages, and the maximum value for each of the columns. Then we now had to look at the correlation between these data. So this we use the heat map. So for the various on the vertical and the horizontal, for all the parameters in the data set, there is a correlation between them. The scale here on the right shows the black shows no correlation towards the white that shows there's a correlation 1.0 to minus 0.6. As it goes down, no correlation. So the darker the color, no correlation. The lighter the color, there is a correlation. So there's correlation where there is 1 between the parameters in the data set. And then we perform the set index code to enable us set the description column as the index as we want to progress with our EDA. So then, just to truncate our data for the exercise, we had to drop off some of the rows 0 to 10, 11 to 32, 85, and 3,300 to row 6, 7, 6, 4 rows. Were all eliminated, and then we now displayed the new data set DF3, and we can see that here as shown. It now has 17 rows and 34 columns. And then to create the Pareto chart, we had to sort the emissions column in descending order. Ascending is equals to false. So the intent is to get our column in descending order. Here. So, and then we now performed the Pareto plot code itself. So this code now with the colors and the specification of the font now generated the code. So they generated the plot. So from this plot we can see that the 2 outstanding emissions are from vehicles that are SUV type vehicles because they cross the 80% line, so they contribute to greater emission. So eliminating it will significantly reduce emissions. Thank you very much.